Let's talk about how to calculate the gram molecular weight of a gas. And I'm going to use three gases used in healthcare or the medical profession. I'm going to look at specifically for this example, I'm going to use oxygen or O2, helium, and nitrous oxide. Why is gram molecular weight important? So gram molecular weight is needed to calculate the density of a gas or a gas mixture. So it's just one component for the density calculation, which I'll be doing later in another presentation. Now, how do we calculate gram molecular weight? All you have to do is add up all the atomic weights of each atom contained in a molecule. So it's the sum of all the atomic weights. If you do not know the atomic weight, well, the easiest thing to do is just look at the periodic table. So here's the periodic table, and we're going to look at a few gases as examples. And the first thing we're going to look at is we're going to look at helium. So we're going to look over here at this portion of the table here. So let's calculate the atomic weight of helium. So here's helium. And we're not going to calculate the atomic weight, sorry, we're going to calculate the gram molecular weight. However, we're going to look at the atomic weight of helium first. As you notice down here, this under here is the atomic weight. So the atomic weight of helium is approximately 4 grams. Now I also said you needed to add the sum of all atomic weights contained in a molecule, an atom in every molecule. So it only has one molecule, so the gram molecular weight of helium is only 4 grams. So it is actually equal to its atomic weight. That's a very easy one. Now let's calculate the gram molecular weight of oxygen. So I'm just going to highlight oxygen here. I'm going to change my colors to orange, and here is oxygen. And if you notice, the atomic weight of oxygen is approximately 16 grams. However, if we look at oxygen's makeup, you notice it has 2 molecules here. So we need to add the atomic by 2. So the gram molecular weight of oxygen is 16 grams plus 16 grams because there's 2 molecules, and that gives me a oxygen's gram molecular weight of 32 grams. Now what's the gram molecular weight of a nitrous oxide? So for nitrous oxide, it has actually 2 gases. One is nitrogen, and the other one is oxygen, right side by side. So nitrogen has approximately atomic weight of 14, and oxygen, as we stated before, has atomic weight of approximately 16. So let's look at the chemical structure of nitrous oxide. And as you can see, there's 2 nitrogen molecules, and there's only 1 oxygen. So this is going to be 16 grams plus the 14 grams plus the 14 grams. And I just rewrote it here. I used the nitrogen first and then the oxygen, and that gives me nitrous oxide's gram molecular weight of 44 grams. So now that's gram molecular weight.